Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we're doing IXL K7, which is proofs involving congruent triangles, and this time it is basically just a review of K2 and K4. We are now going to be seeing a lot of diagrams, and they ask us to prove the triangles are congruent by all four of our theorems: SSS, SAS, ASA, and AAS. Okay, and just like K2 and K4, if the statement is toward the end, the reason typically for that statement is going to be one of our four main theorems. And so we'll look and see what we are given here. And we are given two triangles. And let's see, what else are we given? We're given that certain angles are the same, GFI, GFI. So this angle right there is congruent with this one right here. Okay. We are given that GH is perpendicular with FI, okay, meaning that not only is this angle 90, this one is 90 as well, okay, so we have an angle and an angle, angle and an angle, so we're getting pretty close. Then we know that angle FIG is going to be congruent with FIH, yes, they're going to be the same. We know that FI and FI are the same because of reflexive property. And the reason why that is because we know these two triangles share a side, right? This is both kind of the long leg of each of these triangles. So since they share the leg, it's clearly going to be the same, which means we have a very clear ASA, an angle followed by a side followed by an angle between both triangles. So we're going to go to our reason here and do angle, side, and then angle. And there we go. Okay. Complete the proof. Okay, so we have GFK, and then HIJ are going to be congruent. So the single rings right here. And I'm just going to jump ahead and see that these two rings right here are also congruent, and also that these tick marks right here also show congruence. So we have an angle, and then followed by a side, an angle, followed by a side. So that's going to be AAS toward the end here. Because again, the statement is toward the end. So angle, followed by side. Cool. Okay. So we know that triangle EFH, so this middle triangle here is equilateral, meaning all three of these sides are going to be congruent, the same length, right? We know that H is the midpoint of GI, so this point right here is halfway between G and I, meaning that it's going to split GI into two equal halves, meaning the key word there, equal, meaning these two are going to be congruent now, right? In the midpoint, and FG is congruent with EI. So we also know that these two sides are going to be congruent. So we know these two sides, those two sides, and these two sides are going to be congruent because of the equilateral triangle. So it's no surprise that we see toward the end here, they say we know they are congruent because of the SSS theorem. But we got to go to the step right here, and we have to indicate the reasoning as to why we know EH is going to be congruent with FH. So let's go back here. And we see we have a few options here. First option is the additive property of length. No, we are not doing anything adding related. All right angles are congruent. We are not dealing with right angles. Definition of angle bisector. No, because again, we're dealing with these two things, right? No angle bisector is involved. Definition of equilateral triangle. Although that could be it. Definition of midpoint. It has nothing to do with these two lines specifically. Vertical angle theorem, again, not even dealing with angles, we just have sides there, and that's going to be it. So the clear answer is the definition of equilateral triangle. Like I was even saying before we were looking at the options, we know these two are the same because that is an equilateral triangle is what they tell us. So okay, so for this problem here, we see that TW is bisecting UWY, UWY, so right here, and so that means it's going to cut these two in half, right? And then V is congruent with x. So angle V and x are going to be the same. Complete the proof. Okay, so we go down, and they already gave us that it's going to be proven with AAS, so we're just going to jump to the statement here, the step, and see what we're going with. So it looks like between step 5 and step 6, both are saying that the measure for angle TWX, oop, that's not true, okay. So we go down to step 6 here, and it's saying that the measure for angle TWV, so this angle right here, is going to equal, or it's a combination of TWU, and then UWV. So all it's saying is this entire angle is a combination of this little angle and this little angle. So what is that called? Is that going to be the additive property of angle measure? Yeah, probably. Additive property of length, we're not doing anything with the length, right? We're doing, this has to do with measures for angles. All right angles are congruent, nothing to do with right angles. Linear pair sum up to 180, no. Definition of an angle bisector, no. Right here, there's no angle bisector. That's what they were showing for this angle here. That's what they were telling us. Definition of equilateral triangle, no, nothing to do with equilateral triangle. Definition of midpoint, nothing to do with this, the combination of these two angles there. And then vertical angle, definitely not. So that means we just have the angle measure that is left. Okay, and that is where I'm going to stop. Usually with my classes, I stop at 60 for the proofs. So just know as you reach 60 and get higher, they give you multiple reasons that you have to find, but same type of thing. So just know that toward the end is usually going to be one of the 4 theorems, and then in between just use process of elimination with some of the reasons that we've gone over in class. Okay, that is all. So study hard, stay safe, and I'll catch you for the next IXL tutorial. Goodbye.